Okay, we've done the fuel volume test, and at this point it seems to be fine. The spray pattern looks good on all of them. Don't see any streaming, and all of them are equal. Now, all of them may be pumping out too much fuel. I really don't know if the injector pattern that I got, or the pulse width of the amount of time that it's injecting fuel, is appropriate or not, because I don't have a known good. But at this point, we're very confident that it is not running because it's rich. So I guess we're going to have to make some checks at the computer. There is a series of ohm checks and voltage checks to check kind of the sensors and the electrical inputs to the computer and the electrical outputs of the computer. So we will pull the computer out and do those checks. Here's how you make some basic checks at the computer on a Porsche 914. It may be slightly different depending on the year of and engine size of your 914. Alright, so this is diagnosing the fuel system on a Porsche 914 with resistance checks and voltage checks at the computer. We have the computer out. This is the computer here. I'll just move it out of our way here. And this is the connector that plugs into the computer. All the wires are white, but they are numbered, and there is, you can also count. It goes 1 to 24, if I remember right. 24 is empty, so you might as well say 1 to 23. So if you find a wiring schematic for this, which is a little hard to come by, but maybe you have it in a Haynes manual, or there used to be some on the internet, but they're getting a little bit harder to find because Porsche shut them down. But if you jump from certain poles and measure resistance, you can tell that the device is plugged in, the wires are intact to it, and that it has the appropriate resistance. So between terminals 1 and 13, it is the air temperature sensor, and it should be approximately 300 ohms at 68 degrees Fahrenheit. So here I have back probed into terminal 1, and I'm going to find 13, and that's this one right here. And as I touch it, it should have approximately 300 ohms. 302. That ain't bad. So that tells us that the temp sensor is there, that it's plugged in, and that the wires are intact to it. Doesn't 100% tell us that the temp sensor is good, but at least good enough to where it has the right resistance at this temperature. So on the next check we want to do is for the fuel injector for cylinder number 1, and that is between terminal 3. Terminal 2 is empty, which is why we're skipping it. And ground. So that is terminal 3, and I'm going to touch the negative terminal of the battery, and it shows exactly 3 ohms. And so that tells us that the fuel injector is there, it's plugged in, it's at least the right ohm reading right now. That doesn't tell you whether the fuel injector is stuck or anything like that. It just tells you that it's there and the wiring harness is intact and plugged in. The next is between 4 and ground, and that's the number 4 fuel injector. And it should also be less than 3 ohms, and 2.9 ain't bad. And that shows us the same things I said about the other injector. And then between 5 and ground is the number 2 fuel injector, and once again should be about 3 ohms. Between number 6 and ground is the number 3 injector, and that should be less than 3 ohms. Now number 7 goes to the MAP sensor, manifold pressure sensor. And between that and terminal 15 should be 90 ohms. So once again, between number 7 and 15, let me find 15. 18, 16, that'd be 15 there. And what I say, 90 ohms, and that's 89.2. So that kind of tells you that the pressure sensor is at least good at this pressure. I have a note here that says make sure each lead that there is no continuity to the case of the pressure sensor. So I'm going to reach down here, and I have the pressure sensor just hanging here. You can just barely see it there, but I'm going to touch the case and there is no continuity to the case. I would assume that might mean that through water or some type of internal short, it would short to the case. And then, by the way, that was the primary coil of the pressure sensor. Between number 8 and number 10 is the secondary coil. So here's number 8, and then 9, 10, and this is the secondary coil of the pressure sensor. And 350 ohms is what it should be, and 351 ain't bad. And once again, you want to make sure there is no short to the housing of the pressure sensor. Touching it, and it is not showing continuity there. So the next check is for pin number 9. And pin number 9 goes to the accelerator pump contact track number 1. And what this should have is continuity to ground 10 times from closed throttle to open throttle. So I'm simply going to take my lead and touch it to the negative battery terminal and leave it there. And then I'm going to open the throttle, and we should see this beep 10 times as I slowly open the throttle. And I'll open it nice and slow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's pretty much working. That doesn't mean it's adjusted properly. It just means that the sensor is opening and closing 10 times. Now between number 20 and ground, this takes this out of order, but since we're doing the throttle sensor, it should do the same thing. 10 indications of continuity from closed to open. Okay, so that was approximately 10. I didn't really count. I was just making sure it was opening and closing. The next prong, we're going back into sequence here, is 11, because we've already done 10 when we checked the secondary coil of the pressure sensor. And that's beeping because I still have it hooked to ground. That is the ECU ground circuit. So I am touching ground here. That has very low resistance to ground, so that means it's probably a good ground. I'm going to turn this off for just a second here so I can talk. Okay, so we ohm checked this and it checked reasonably okay, but the best way to check this is to see that it can actually carry current. So we do this with a headlight bulb, and I have jumped power on this alligator clip right here from the battery, and now I'm going to jump ground to our prong here, and that should light the headlight bulb brightly if it can carry current. And I gotta say, that's so bright it hurts my eyes. Gotta wear shades. Okay, we might need this bulb again for another ground, or maybe for a power. So we're going to move now to number 12. And number 12 is to the points. Not the points that fire the coil that make the spark jump through the spark plug, but these are the points that are below that in the distributor that, as I've read and researched, they kind of trigger the injectors. Now I'm not sure if they trigger them directly or whether the computer takes that information and modifies it. Doesn't matter, but the point is that it will give continuity between 12 and 21 as we crank it. There's 21 right there. I can see it written on the wire. And this may be hard to interpret when we're cranking the engine, but we're going to go ahead. Hang on. It's very hard to interpret because it's happening so fast, but you could see the bottom of the meter flashing with a solid bar down here, and because it was going off limits to connected and then not connected. Let's try it again like this. Crank it. shut it off. A scope is a much better way of doing this because you can see it in real time. But obviously we have no continuity right now, and just bump it. Bump it again. Oops, I'm on the wrong prong. Bump it. Bump it. See, there it's stopped in an area where the points are not connected, and then bump it again. Again. A little bit longer. Again. Again. And what you're seeing there is sometimes the engine will stop with the points open, and sometimes the engine will stop with the points closed. So when it's open, it'll say off limits, and when it's closed, it'll beep for continuity. So to check the other points, not the ones for spark, but the other points that trigger the injectors, you go from the same pin 12 to 22. And we're going to do that the same way by bumping it. Okay, so right now we have continuity, bump it. No continuity, bump it. It beeped just there for a second. No continuity, beep, go. Continuity, bump it. And you see it went to no continuity there for a second. Now it's got continuity again. Bump it. And it went to no continuity. Interesting part is this side will have, well, this side will be open, and this side will have continuity in opposite of each other. Is what it seems to be. Okay, we are going to move from 12 to 16. 16, you say, why are we skipping 13, 14, 15 all the way to 16? Because 13 we checked in the very first test of the air temperature sensor, 14's empty, and 15 we checked on the pressure sensor primary coil. So we're moving all the way to 16, and that is a power wire for the computer. So when we turn the key on, let me turn this to voltage. So when we turn the key on, we should see 12 volts there. And just because we have this stuff here already, I'm going to hook the headlight bulb to that power to make sure that power doesn't have some resistance in it, making it incapable of carrying current. And obviously that's pretty bright, so that's a good power source for the computer. Okay, so there is another power to this computer, and it's on pin number 24. So we're going to go ahead and check that one now. And that has 11.73 volts, which should be good. And I'm going to jump that power to my headlight bulb to make sure it can carry current, and that's nice and bright. So we went from 12 to 16, and then 17 is next. So 17's right here, and this is the TPS idle contact, the throttle position sensor idle contact, and that should have less than 5 ohms when the throttle is closed, and should go to open when the throttle is opened a little bit. So I need to switch to resistance, and I'll go ahead and turn the beeper on, but that's going to be annoying. So you can see there that it's got 1 ohm of resistance to ground, and when we open the throttle just a little bit, it should go open, and it did. Now I'm letting off, open, letting off. So that's the way that's supposed to work. Okay, we're moving from 17 to 18, and this one is, I'm going to turn the meter to voltage here, and this is 12 volts that comes from the starting circuit. This computer obviously wants to know when you're turning the key to the start position, so this should get 12 volts when we turn the key to the start position. I'm going to go ahead and hook this to our light bulb at the same time, and that way we can do the voltage check and the brightness check for to see if it'll carry current at the same time. Go ahead. Okay. It showed 9 volts there, but it was able to light this bulb just fine. Our battery is getting a little weak. Obviously there's a voltage drop also when the starter is running. Okay, we're going to move this from number 18 to number 19. And 19, you do something slightly different here. You have to check continuity between there And that relay box over there, if you see there, can you point to that white connector with 4 prongs there? Go ahead and unplug that. And then hold it up to where I can see inside of it. You check continuity from here to the prong number 3 on that connector right there. Now the way you determine what prong number 3 is you can look at this diagram here, and on this relay board, which is that connector plugs into, prong number 3 is this upper left one. It's literally saying ground to fuel pump relay, and that's what we're checking. We're checking that we have continuity from our computer connector to this prong number 3. So I'll give Cortland my ohm meter lead, and I'll hold the ohm meter in the screen, and I better turn it to ohms, and we should have continuity there, and we do. That up. Okay, we are going to move from 19 to 23. Why am I skipping 20, 21, and 22, you ask? Because we checked those in earlier tests. And from there, that is for the cylinder head temperature sensor. And you check between here and ground, so I'm going to put my other lead on the negative battery terminal. And it should be 2K ohms resistance, that's 2,000 ohms resistance at 68 degrees Fahrenheit for all but 1973 2.0. The resistance check here is different based on the engine size and the year. So if it's a 1973 with a 2.0, it'd be 1.2K ohms, that's 1,200 ohms. And if it's anything else, any other 914, my notes here say that it should be 2K ohms resistance, that's 2,000 ohms resistance at 68 degrees Fahrenheit. Now, I'm fairly confident that this isn't going to show us a reading because this meter will not do resistance that high. Most digital ohm meters will not push current through a resistance that high, so you have to get a analog meter to check this type of stuff. So let me go grab my analog meter. Away with a nice expensive fluke meter, which is a great meter by the way, everyone should own one. And in with a $20 Radio Shack meter. You could probably buy this same meter, I don't know if you could find it in Radio Shack anymore, because Radio Shack, I don't even know if they exist anymore. But you can probably find another cheap meter like this for even less on the internet today. But I think I paid 20 bucks for it 20 years ago. So I'm putting the ground lead on the negative terminal of the battery. And then I've already calibrated this. You have to do a small calibration on this type of analog meter. And you can look up on your meter if you have to do that or not. And I'm going to touch the back probe that I already have there, and it should show 1.2. I have hooked the negative lead to the negative post of the battery, and I'm touching this right here, and I'm getting no resistance reading. Now, in order to confirm that this meter is kind of working, I'm going to touch the block of the car, and you can see the needle moves. Might be a little bit hard to see on video, but you can at least see that it is moving when I touch ground. So this one does seem to be open. That is a problem, and that does complete the series of checks that are done at the computer, checking through the wiring harness to see that all these components are there and working and the wires are intact to them. And as we can see, our last check did show that something was not intact and something is not there and working. Is that there is this wire here that is not connected to anything, and I'm pretty sure that's the cylinder head temperature sensor. Okay, we have found where the cylinder head temperature sensor wire comes out of the harness, and that's that alligator clip down there. There ain't much left of it there, but we are going to alligator clip to it and then hook to this other end. and then we'll see if this thing runs. Interesting side note, this is hooked into the cylinder head temperature sensor circuit, and it has a resistance reading of about 287 ohms. Okay, on this 914 computer, you could see there those copper things. They are where that connector mounts, and inside this connector there is definitely some corrosion, very minor on some of these connectors, and also there is a little bit of stretching out on these terminals. So what I would suggest doing is taking a scribe. I don't have a scribe handy to show you, but taking a scribe and very gently prying each one of the connectors down like this and upwards like this in order to have a good fit again. You better be real careful if you do that, because if you break these, where are you going to get this connector at? You're going to have a real hard time. I've already done that, and also I wanted to show you my technique for cleaning the corrosion. Obviously I scratched at it a little bit with the scribe, but I also took this piece of sandpaper and folded it over like this, and I put it in here and just sand it back and forth a little bit, and that gets some of the corrosion off, maybe ensures a good connection, and a little bit of dielectric grease across there will ensure a good connection on your computer. We have run an alligator clip as a temporary repair to hook up the cylinder head temperature sensor, and maybe we'll get lucky and that'll fix it. Let's start it and see. Alright, obviously I ran with the cylinder head temperature sensor connected, and this was a very difficult diagnosis for me. I own a 75 914, and usually when you do work on a car, a similar car to one of your projects, it motivates you to work on that project. My Porsche is a running, driving car. It just sits all the time, and we have other work to do to this car, including brakes and vacuum hoses and stuff like that. Might even fix blinkers and headlights and stuff like that if that stuff isn't working. We are going to, in this video here, if you learn anything from this video, including electrical tests at the computer, fuel flow tests, injector spray pattern, anything like that, then feel free to donate at my website at www.kansascitytdi.com, and don't forget to click the like and subscribe button. And if you have a Porsche like this and you want me to work on it, just give me a call and let me know. Okay, I've hooked the scope back to it in order to show the injector pattern with the cylinder head temperature sensor hooked up and working, and with the car running. And what I'm seeing at this point is 11.3 volts on the injector power wire. And let me zoom in here. So 11.3 volts there. So I dragged out some rulers, and our pulse width is 2.52 milliseconds. And I did save the original one, so let me pull that one up so we can make a comparison there. Okay, so this is the original scope pattern, and you can see based on the voltage ruler it's at 8.6 volts, and it's a much flatter line when the cylinder head temperature sensor isn't working or is disconnected, as it was in our situation, and that's at 2.5 volts. And but the problem is our time factor. Our pulse width, based on these rulers, from there to there is 62 milliseconds, and with a running car it was 2 point something milliseconds. So obviously injecting more fuel and floods out the cylinder and won't run.